right now.
I'm not.
What? Exactly.
I said math.
Sure. Hey, greetings and welcome, friends. We're taking a look at a couple more problems related to do with properties of exponents. And the first thing, we've already seen the props. We might as well just jump into some stuff. I wanted us to look at a table of values and consider our thoughts about zero exponents as well as negative exponents. So check this little table out here. Let's say I've got like, yeah, we'll have the exponential form. And then value over here. Sounds good to me. Let's say I've got like 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st. Let's start with that. What is 2 to the 1st? Does anyone know?
It's equal to 2.
It's equal to 2. I like it. How about 2 squared?
It's equal to 4.
4, and then we've got 8, and then we've got 16, and so forth. What is the relationship when I'm, going from this direction up? Right, from 2 to 4, 4 to 8, 8 to 16. What am I doing?
It's doubling.
I'm doubling it, right? Doubling.
I'm pretty sure that's not how it works.
No? No?
I'm not pretty sure.
Okay. So to go backwards this way, what pattern is occurring?
It is cutting itself in half.
Halving it. Halving, halfing, halfling, hobbiting. There we go. So if I wanted to figure out what not 20 is, but 2 to the 0 is, I would expect that I would be able to continue that halving pattern. And 2 divided by 2, if I cut that in half, I get 1. Hey, it works. And consider this. What if I extended that further? What's 2 to the negative first? What's half of 1? A half. What? What is 2 to the negative second? Half of a half is a quarter. Ooh. I think it seems to work.
This is crazy.
And half of a quarter is an eighth. Yeah. So it appears as though these values are related to these values, right? Here and here. Would you agree? It's just they're reciprocals. Yeah. So this is the same as 1 over 2 to the first. This is the same as 1 over 2 to the second. This is the same as 1 over 2 to the third. So I just wanted to point that out to you just to give you kind of, if you're looking for more like concrete, less abstract justification for negative exponents being reciprocals, I figured that this example is a little bit helpful for us, for sure. So let's consider this un otro example.
Ooh. French.
No Spanish.
Ultra is also how you say another in French.
Wow, it's
Huh.
Spanish
Interesting.
too.
Let's say I want to simplify the following. Simplify x to the negative third, y squared over z to the negative first. Okay. Now, you probably saw some problems like this last night, but I've got another way of explaining it that I like, and I like to believe anyway that this potentially is a little bit more helpful. So imagine, it's like story time here. Imagine you are a landlord and you manage a 2-story apartment complex. Good stuff. And you've got some tenants living in your apartment. You've got X, he's hanging out, Y, and Z, right? And so some of these people are really happy living there or where they are, and other people not so happy. So consider Y, for instance. Y loves living on the 2nd floor apartment, right? Because when Y looks out their window, they see like awesome mountain views, and they're just like, this is so amazing. I love living on the 2nd floor. Whereas if like Y moved downstairs, they'd look out their window and just see like this sad, like gross, grimy dumpster that says Squidward smells on it.
Oh, that's terrible.
And like, yeah, like they don't want to look out their window and see a dumpster, right? So Y is happy. So as a landlord, would you want to mess up the joy that Y has right now?
Not right now.
No, not right now anyway. Exactly. Maybe when their rent check bounces, then we'll talk. But yeah, Y's happy, so let's not mess that up. But it turns out x is sad. How do I know it's sad? Because it's got this negative exponent.
Because when it looks outside of its window, there's a big giant wall.
No, it's actually almost. Maybe that is true. But it turns out x, the thing x hates, when x gets home from the grocery store, all right, here's my awesome car. Oh, actually, no, it suddenly became like this weird van truck thing. Here we go. So x gets home from the grocery store and ends up having to like X is complaining to you one day, like, I have to carry my groceries up the stairs, and then I walk back down and carry more groceries upstairs, and blah! X hates it and is furious. So what could we do to solve X's problem?
Move it downstairs.
Yeah, let's move him downstairs. He's probably going to love it downstairs, because then he can just bring his groceries like this way and that, and right, and no stairs to climb. Good news for X. All right, so good. I think we found a good solution for X. However, Z starts complaining to you. You know what Z's saying?
What is he saying?
Z is like, man, I hate living downstairs, right? Because Y is upstairs all night playing Guitar Hero World Tour with the drum set, and all I hear is like the bass pedal, boom, 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 like hitting my ceiling, and not only that, shaking, of course, Z is an eccentric person, shaking and rumbling the priceless chandelier collection that Z has. Right? And Z's just like, what's up? I can't stand it anymore. Right? So what's our solution for Z?
We're going to put him upstairs.
Yeah, let's put him upstairs. Right up here, how about? I like it. I like it a lot. So what's this going to end up looking like as an end
So
result?
now it's going to be
So Y's upstairs.
y to the second of z.
Z's upstairs with a positive exponent now because he loves it. He loves it upstairs. Over x to the third, right? So x is happy. And x doesn't actually mind the bass pedal bumping all night because maybe like the groceries that x brings in, like x preserves pickles apparently, and the vibrations from the bass pedal are vibrating and oscillating the oxygen bubbles or whatever in his jars, and it makes the pickles last longer. That's probably what happens. So x, everyone's happy, and you're a great landlord. Congratulations.
Whoa.
Isn't that a wonderful story?
That's a great story.
Pretty good. Tell you what, I've got an even better story for you.
Yes, I love stories.
In your apartment across town.
I'm so excited.
Here we go.
And it's actually good all week.
X to the negative third
Until Friday.
over x to the 4. Your apartment across town. This one only has 2 tenants in it, for what we know now anyway. And it's a 2-story apartment, right? And we've got like one happy tenant and one sad tenant. But they actually have a little bit in common. They're both like X's, right? And one day when they're hanging out on the porch, right? They're sitting in their chairs, like hanging out. Here's a little porch chair, right? They see each other and they're like, oh, love at first sight. And you're like a little matchmaker landlord, you are, aren't you? And they fall in love, and then like they date and they get married, and they're like, Mr. Landlord or Mrs. Landlord, can we move into the same apartment? And you're like, yeah, why would I stop you? I mean, like, I don't control your life. Yeah, you can rent the same apartment. And then they're stuck in a dilemma. Should this X move downstairs, or should this X move upstairs?
Well, the
Thoughts?
X downstairs happy.
The X downstairs is happy right now, right? That's true. That's true.
The one upstairs is scared of heights.
And the one upstairs maybe is scared of heights or something. Now when I'm dividing 2 variables of the same base, what was our rule? What do we do with the exponents?
You subtract.
We subtract them. So think about this. If I moved this one upstairs, -3 minus 4, that'd be -7, and then they'd be unhappy living on the 2nd floor, and I'd have to move all of their furniture again downstairs to get an X to the 7th. And that's not cool. That's not cool. So here's my little rule of thumb. I think about it this way. Whichever one is moving into whichever other one's apartment, all right, oh, I just deleted the chair legs there. Always move the one with a smaller exponent. Always. Yeah, all the time. All right, move the little guy to the big guy. Because think about it like, this person has like less stuff in their apartment, and I'd rather move fewer couches and TVs and nightstands or whatever and bookshelves downstairs, then move more stuff upstairs, and end up with a negative exponent anyway.
So -3 minus 4 is going to be 7 though.
So this is going to be x to the, and I still subtract the exponents, 4 minus a -3, because I'm subtracting the little guy from the big guy. All right? So that double negative means adding, I agree. So that's going to be x to the positive 7th. But now we got a problem. No one's living upstairs now.
Doesn't matter.
One.
Oh,
You have one apartment for sale.
well, it turns out it's a vacant apartment, and wherever there's a vacant apartment, one sneaks in. All right? And it turns out one, right, we've seen one before. It's the invisible hobbit wearing a ring, right? It's like Harry Potter wearing a cloak of invisibility, right? It turns out that one, not only is this hobbit wearing a ring, but it's kind of a creepy hobbit that's homeless and squats in apartments. Like they break in, like he saw the fire escape and saw that no lights were on a couple nights in a row. So one snuck up in and moved in and is now living there rent-free, which is kind of bad news for you as a landlord.
Nothing you can do about it.
Yeah, there's kind of nothing you can do about it.
Why don't I call the police?
Well, yeah, it's crazy stuff. But interestingly enough, that's not the only creepy hobbit here. It turns out, guys, this is really sketchy.
One.
There's a one hiding right in their closet, like the whole time. What? The phone call's coming from inside the house. Oh, that's so weird. That's so weird. But anyways, but nonetheless, regardless of ones in these creepy
That
hobbits,
happened in Sherlock last night.
x to the 7th is positive. Everyone's happy. It was a love story. How wonderful. How wonderful. Let's consider one last example. Let's see if we can apply all these principles quickly. Let's see. Let's say I've got x to the 7th, y to the 3rd, z to the -6th, over y to the 3rd, z to the -2nd.
Whoa.
Okay, so now we've got a really big apartment building going on here. This is also across town.
Is this like a complex?
Yeah. Big apartment, right? How great is this? All right, so let's see if you can tell me what's going to happen. X to the 7th, what happens with them?
He's just gonna chill upstairs.
Yeah, X to the 7th is happy. Let's leave them upstairs. They're fine. Nothing wrong with that.
Why?
What about the Y's?
The
Oh wait, they're
Y-
the same. I
They
think
just moved out.
they fall in love. I think though.
And the
right?
the Y upstairs wants to move downstairs.
Well, actually, they both have the same amount of stuff, so it technically doesn't matter which one moves where. Let's say I just move it upstairs for now, I guess. What about the Z's? What's going on with
Oh
them?
boy, they are sad. They're kind of depressed.
They're both sad,
The
but
guy downstairs is going upstairs.
who has less stuff?
I mean the guy upstairs.
Yeah, -6 is smaller than -2. So let's see what happens here. So I'm going to have x to the 7th hanging out. I'll have y to the 3 minus 3, which is 0.
Which is 1.
Oh, slow down. Over z to the -2, I'm going to write this out, minus a -6, which is +4. Okay, so that's z to the 4th downstairs. Good news. X to the 7th upstairs. But what happens with our y?
They move out
They
because their
move
apartment's
out
not
and
big
then
enough.
the creepy.
Or, yeah, or it turns out y to the 0 is equal to 1. It turns out you evicted them. Now they're homeless and they're creepy hobbits. What? Oh, that's so weird. Craziness. Crazy times, huh? But you're left with a happy apartment, happy tenants. Congratulations. And you're like a little matchmaker and also a person who evicts young married couples. Congratulations. Have a great day, internet friends. Bye-bye.